So today is our first prerequisite lesson for the next unit. This lesson, like it says, topic one readiness on your paper, because normally I would have math lab students right from the very start versus like a few weeks in. But really this is helpful for unit two because unit two is where we actually start solving things and actually start doing algebra. Unit one is just statistics, which statistics are super important, but it's not a skill that is tested often on state testing. Like it's tested a little bit. Maybe on your science test, you'll see a lot of the statistics a bit more. But if you really struggle through unit one, then at least it'll kind of help that the rest of the units are not like unit one. I think unit one is very easy in my opinion. I think if it's like the one that you're going to do well on, it's usually unit one. But if you really didn't like it, like know that unit two, unit four are entirely different. We're doing unit three at the end of the year, by the way, so I skipped that one. But um, usually things like spiral and repeat, unit one, you won't really see again until the final exam. So you do still need to like show mastery on those skills for your final exam, but that's not until the end of the semester. Unit two is all about solving equations and inequalities. Today, we are doing a prerequisite lesson for that. So showing mastery on number sense and operations with integers at 80% or higher. What's an integer? Wait, what? I like when you look at your here. Integers are what? A negative number, and it could also be what type number? Negative and positive whole numbers. So basically, I don't want to say whole numbers because whole numbers is technically just positive numbers, but negative and positive non-decimal numbers. Or really, we mean like numbers. So whole numbers would just be positive numbers that aren't decimals. Integers is both. So when I say like we're going to do operations with integers, we're going to do operations with positive and negative numbers. If on the test it says your answer needs to be an integer, it does not want it to be a decimal, and so forth. But anyway, moving on, we're going to learn how to identify and define different types of numbers, and then add, subtract, multiply, and divide. I'm recording right now. I'll link it right here. Here's some videos from previous years if you like to check those out. I don't think we'll necessarily have time to cover order of operations, maybe just a little bit. Most things like order of operations and adding, subtracting, multiplying, dividing integers, most things can be done in a calculator, but it's very important to build fluency, which is why we're going over it. Like life would be a lot easier if you knew the rules too versus the calculator. That way, like, you can see if your answer is right versus, just relying on like, your answer makes sense or not. Instead of having like a traditional homework like normal, you'll just have a look at later to test what you've learned today. And then just reminding you of these things that are past due. I did get a couple resubmissions that still need to be graded and passed back. Know that everything is updated within 7 days. So if it's been longer than 7 days, then you need to tell me, but otherwise, like if it's late, like 2 weeks late, and you want me to grade it right then and there, like that's not going to happen. It's graded within 7 days. So the scavenger hunt was a good chunk of points. The box plot foldable still. Eventually I'll stop reminding you of this stuff, but still like some people have some silly things missing. So just make sure, and this is actually today, not tomorrow, fix that. If you haven't had algebra yet today, the retake is supposed to be today, so I hope you're prepared. But the rest of us have already retaken it, so we're going to start preparing for unit two. All right, so we have these different type of numbers that we're going to define because often like on your tests, it'll say that it wants your number to be like rational or irrational or something equivalent. It would be nice if you knew what type of number it was asking for. So for the first one, it says that it's all positive whole numbers, not including 0. That would be our natural numbers. So like how you count. So all positive whole numbers, not including 0. Some examples would be like 1, 2, 3, 4, and so on. Give me another example of a natural number. Yep. I mean, it is. Any other ones? Okay, what would not be a natural number? 23 is a natural number. 4.5, because that would be a decimal, right? It said all positive whole numbers. 4.5 would not be a natural number. All right, next one. It says all positive whole numbers, including 0. This category does not include any negative whole numbers. That would just be whole numbers. So 0 is technically a whole number. So the only thing in addition to the previous list is that we're also including 0. So if it wants your answer rounded to the nearest whole number, if it's closer to 0 than it is to 1, then yes, you can say 0. The next one. We have positive and negative whole numbers, including 0. This category does not include any fractions or decimals. What must be? It includes positive and negatives. Okay, good. This is integer. So some examples, and you can start really anywhere, but I'm going to start at -2. I'm going to end at +2, but as long as it's not a decimal or a fraction, it can be positive or negative. It can include 0. Is 0 positive or negative? Okay, good. It's neither. But yes, it does include 0s too. Questions so far? Are we good? Okay. Then this next one, a number that can be expressed as a ratio of 2 numbers, like a fraction. This includes decimals that terminate or repeat. I don't think any of them start with B.
Yeah, I don't think so.
Okay, so these would be what we call our rational numbers. So that is including everything that's above it. It can be an integer, a whole number, or a natural number. But now it also includes decimals that terminate or repeat. What does terminate mean? They stop. They stop. And then repeat would be like repeating any sequence. It could be the same number. It could be the same 2 numbers, the same 5 numbers. Yep, if it went on forever with the same number. So we'll put includes all of above. Because it does include all of those. And then other examples would be, okay, so like 1/3 is a decimal that goes on forever, that repeats. It's 0.3333. I does not repeat. It can repeat the same sequence. So like if it was like 0.271, 271, that still would be something that is repeating. but it has to either end or it needs to repeat. And all of these numbers above it can be written as a decimal if I just put like 1.0, 2.0. Or I could write it as a fraction if I do like 3 over 1, 4 over 1. So all fractions either end or they repeat for the decimal. And then all the other ones above it are also fractions. Does that make sense? Any questions? Okay. Now we're going to talk about irrational numbers, which is a number that cannot be expressed as a ratio of two numbers, so no fractions, but it's decimals that never stop or repeat. So let's add that in there. They never stop or repeat. If it's a decimal that repeats, then we would call it rational. So pi would fit into this. And then any like non-perfect square root would also fit into this. So like if I did the square root of 35. Show you that in the calculator. So obviously the calculator cannot go on forever, like it has to stop at some point and it'll always round wherever like the window is. If I try to take the square root of 35, which I know is not a perfect square, this is what we mean by a decimal that goes on forever without repeating. This window only shows me so much, and there's nothing like repeating, like a random pattern. Here is pi for reference, this little button over here. There's the decimal that goes on forever without. All right, questions on that? Okay. So any fraction you can think of is rational because it's either a decimal that like ends or repeats. So like 8/9, it repeats the 8. It rounds here because that's all it does. All right. So that's our irrational numbers. For our last category, that's going to be our real numbers, which includes all of the above, even rational and irrational. In Algebra 3-4, you will learn about imaginary numbers. So that's why you might be like, okay, real numbers, like well, eventually you'll learn about imaginary numbers.
That's the numbers that.
No.
Big number.
You'll love it when you get there. It's where they use like I for like imaginary and like I squared and I cubed and all that stuff. But for now in algebra, it's just these different types. Questions on these vocab? Okay. So now we're going to get into operations with integers. And today when we do the flow kit, I'm going to ask you not to use a calculator. In any other situation, please, I prefer you to use a calculator. But today, to practice fluency, we're going to not use the calculator. But we're just going to practice. First, it starts off easy. If they're the same sign, you're going to add the numbers together and keep the sign. So like when I'm adding two positives, they're both positive, my answer will always be positives. If I add two positives, my answer will always be, okay, good. So 4 plus 5 is 9, easy, right? 2 plus 3 is, okay, good. Over here, this works for negatives. Like if I add two negatives, my answer will always be negative. And when we say like find the sum, because that's what the rule is, it says find the sum and keep the sign. We really mean like almost like ignore the negative for a second. 4 plus 5 is 9. But since they're both negative, it's a negative 9. Does that make sense? Yeah. So -2 plus -3 is what? Okay. Now for different signs. It just depends which is the larger number, what the sign will be. And you're finding the difference of the numbers. So almost ignore the negatives when I say find the difference. Like what's the difference between 6 and 2?
Oh, negative.
No, okay, so listen, all of you. All of you should be able to answer me. Let me say it again. When we say like find the difference, if they're opposite signs, we almost mean like ignore the negative for a second. What's the difference between 6 and 2? And that's in this situation too. The difference between 6 and 2 is also 4. But the sign that you keep depends on which number is larger. If you say larger, we mean like base, like without the negative. So over here, the 6 would technically be larger than a 2, so that's why we're keeping the negative. Again, 6 is larger than the 2, but this time the 6 is positive, so that's why it was a positive 4. Does that make sense?
Yeah.
Okay. I'm gonna make one up right now. So let's see. And you're supposed to be taking notes.
Wait, what?
That's why I gave you a paper. That was just like what I'm gonna use. Okay. Let's do 8 minus 3. What's that?
5.
Okay, we probably didn't need to think too hard for that one. Now let's do -9 plus 4. What is it? Okay, good. So when there's different signs, and really, I probably shouldn't have put that. I probably should have put 8 plus -3 and 6 plus -2, but same difference. You find the difference and you keep the sign of the larger number. All right, now in any subtraction problem, no matter what it is, you can add the opposite. So let's take like this one for a second, which is really easy. You probably don't even need to think about it too hard. But this is what I mean by add the opposite. Any subtraction problem, you can change the subtraction to addition and make whatever this sign is the opposite. Did you really need to for that one? Probably not. 8 minus 3 is already kind of easy to do. But 8 plus -3 is also positive 5. Because the 8 has it's bigger. And it's positive. So the answer is good. So that one you probably didn't need to do, but then there's problems like this that are kind of challenging. Like an 8 minus a -3. Don't say the answer, just think about it. Think about it. So in all subtraction problems, no matter what they are, you can always add the opposite. So change the subtraction to addition. Change this to a positive because it was negative. What's 8 plus +3? That's easier to do than 8 minus -3, right?
Yeah.
Okay, let's try -4 minus 7 on your own. Do it on your paper. And then 10 minus -13. Try it on your paper. So it doesn't have to require a conversation.
Does it matter what side?
Okay, Lila, -4 minus 7 is what? Let's see, Gracie, 10 minus -13 is what? Okay, so let's see, adding the opposite. So over here, any subtraction problem, no matter what it is, you can add the opposite. -4 plus -7 is easier to do than -4. Okay, that's right there. Oh. Like, I don't know where, like, we think that I'm playing around. I have quizzes ready to go from prior years. We could turn this class into one of those. It's not supposed to be that way, but I cannot have to keep telling the same kids to shut their mouths. Okay, one more, we're taking quiz on there. As I was saying, -4 plus -7 is a lot easier to do than -4 minus 7. They now have the same sign. All I have to do is add the numbers and keep the sign. Over here, this is also a subtraction problem. We can turn it into adding the opposite. That's a lot easier to do than what it was before. Now they have the same signs. They're both positive. That's a lot easier to do and without a calculator. However, you could always check the recalculator, but not today. Questions on this? All right, on to the next one. Now, this is another method. I never learned it until I started teaching math, because honestly, math has always been pretty easy. This strategy down here, I learned from my second grade teacher, and I've remembered ever since. And it's honestly made things so much easier. This over here helps with more of you visual learners. So take like any random problem you can think of. So like -7 minus 3, -4 plus -10. And let's do something. All right. This method has you looking at the sign that is directly in front of the term, which is what you're supposed to do anyways. You're always supposed to keep the sign that's in front of the term. So this is a -7. I'm going to make 7 negative bubbles. One, 2, 3, 4, 5, 6, 7. This 3 is also negative. I'm going to make 3 negative bubbles. Do any of them cancel out?
Yes.
And when I say cancel out, I would mean like a plus and a minus cancel together, right? None of them canceled, right?
Let's see.
How many total negative bubbles do I have? So guess what my answer is going to be? -10. And that's what you can do for any like integer problem. Look at what's in front of each term. If there's nothing in front of the term, what is it assumed to be? So this is a +4. I'm going to do 4 positive bubbles. And then what's the sign in front of this one? So it's a negative, so I need to do 10 negative bubbles. I make sure you have 10 only. And any that cancel out, like a positive and a negative, cancel out. And see what you're left with. What am I left with? 6 negative bubbles, so my answer for this one is -6. 9 minus 1, you probably don't need to do that one, the circle method, but the circle method still works. What's the sign in front of the 9? And if it's not written, it's assumed to be, so I would put 9 positive bubbles. Alright, so that's 2, 6, 9, 8. And then what's the sign in front of this one? 1. Negative. So that would be 1 negative bubble. These cancel out. What am I left with? 8 positive bubbles. My answer is 8. So visually, that's why those other rules work. Because someone probably noticed this and noticed that every time the signs are the same, really, I'm just adding these numbers together and keep the sign. Or like anytime the signs are opposite, and finding the difference and keeping the sign of the bigger number. And so forth. That makes sense? So this is why the other rules work. All you have to do is make sure that you're, if it starts to miss a problem on a test, because you tried adding something in your head, you did it wrong. Or if you're not, if you're trying something in your calculator and it doesn't make sense, you know to go back and do it. There's no rule. Questions? Okay. So then moving on, we're going to talk about multiplying and dividing integers. So those have their own rules. For these, you need to count how many negative signs you have. And if it's an even number of negative signs, your answer will always be positive. What do we mean by even numbers? Let me give me example of even numbers. Okay, is 0 an even number?
Yes.
It is. Will I ever really have like 0? I guess I can have 0, but yeah, we'll include it. So 0, 2, 4, 6, 8, and so on. If you have to ask, if you can write something down in math, you're already. Yes. Yeah, when you guys, like, really, you shouldn't have to ever be asked to take notes. In college, they don't give you note sheets. You just have to, like, take notes on your own. Really, like, in math, all your math teachers give you notes. You can write whatever you want on it. But when kids specifically don't take notes, and then when it comes to finer check time and they have, like, a flat grade on it, I know, like, I now have proof to the parents why your kid is not doing well. When you sit and you don't pick up your pencil at all in math class, what am I? All right, so anyway, even numbers are 0, 2, 4, 6, 8. Down here, if we skip ahead, you can put some examples of odd numbers, which are what? And I doubt you'll ever have to do a multiplication or division problem with more than those that we have listed. But basically, you count how many negative signs you have. The multiplication like normal, like ignoring the negatives almost. And then the sign depends on, did you have an even number of negatives or an odd number of negatives? So NIE, how many negatives do I have in this first one? All right, Sadie, is 0 positive or not? Sorry, is 0 even or odd? So then Olivia, my answer is going to be not necessarily positive. So that an even number of negative signs, like 0 is even, so 0 negative signs, that's an even amount. That means the answer will be positive. The multiplication, hopefully you know your multiplication facts, but if you don't, really have to calculate done. But 3 times 4 is 12, because there's no negative sign, my answer is positive. In the second one, Colby, how many negative signs do I have there? 2. And class 2 is an even or odd number. So 2 negative signs. That's an even amount. So my answer should be doesn't matter what the 2 numbers are that we are multiplying. If there's 2 negative signs, the answer will always be positive. -3 times -4 is positive. Down here, Let's see. Devon, how many negative signs do I have in this first one? Just look at the left side. This one has the answer showing, but you need to count how many negative signs you have. So I have one negative sign. Elena is one even and odd. So when there's an odd amount, the answer is always good. Doesn't matter what two numbers you're multiplying, you still like kind of almost ignore the negative for a second. 3 times 4. But since one of them is negative, the answer will also be. So what's 3 times negative 4? Still negative 12. All right, over here we have 4 numbers multiplied together. By the way, I hope that you guys are not using extra multiplication still, but if you are, stop. Because eventually we will get to variables and we just don't do that anymore in higher grades. Use parentheses, use a dot. But this is 4 numbers multiplied together. It's not 3 minus 1 minus 4 minus 2. They're all being multiplied together. Count how many negative signs there are. So Kaylee, how many negative signs are in this problem? There's 3 negative signs. That's an odd amount. The answer is going to be negative. And you can do the multiplication almost ignoring all the negatives and then just count them at the end. If it's an odd amount, put the negative. If it's an even amount, put a positive. But like 3 times 1 is what? 3. 3 times 4 is what? And then 12 times 2 is 24. But since I had an odd number of negative signs, my answer is going to be negative. Questions on that? Okay, I'm going to give you a series of problems to try. I didn't want to put them in any sort of order because I didn't want you to just like copy what it was for the examples. So let's do 8 times negative 7. Just do it on your paper. Negative 9 times negative 2 on your paper. Do 1 times negative 2 times 4. And 3 times negative 2 times negative 8. Let's see. 5. All right. Ion is 8. What is 8 times negative 7? Okay, can you tell me right now what 8 times negative 7 is? Good. At the very least, so if he couldn't tell me because he didn't know like what 8 times 7 is normally, at the very least I would have asked, well, what should the sign be? And you know, based on what we already talked about, there's only one negative sign. That's an odd amount. My answer should definitely be negative. The 8 times 7 you either have memorized or you can type that in your calculator, but that is how you get that with the right sign. Ariana, what about 1 times negative 2 times 4? Negative 8 is correct. So again, and you can do it in whatever order, but you could count how many negatives there are. Class, how many negatives are there in this? 1. So I know that's an odd amount. My answer should definitely be negative. The rest just kind of go from left to right, I think, like how you read. 1 times 2 is what? 2 times 4 is, and then of course we already checked for the negatives, how many there are, if our answer should be negatives. Yes. Let's see, Anne Marie, what about -9 times -2? +18. Okay. It's two negatives there. When we multiply two negatives, we get a positive. Now this challenge one, did anyone get it? Pearson, what did you get?
240.
Okay, and it should be positive, so that's good. There was only two negatives in this one. That's an even amount. So our answer should definitely be positive. I don't even like doing this math in my head, so I'm going to check it really quickly. But we already checked for the negative, so we know our answer is going to be positive. So I'm doing 3 times 2 times 8 times 5. And that is 240. Good. Any questions on this? Now we were practicing that way to build fluency. Please, in the real world, please use a calculator, check your answers in any other situation. All right, so now we have 12 solid minutes to do this booklet. Any questions from the notes? Ion, did we have a question? Oh, okay. Well, you can use your phone for the booklet once I find where I put it.